Welcome back. The featured solid for this video will be the cylinder. This is probably the one we are all most familiar with. Your pantry or your cupboard at home is probably full of these things. So we have a picture of a cylinder. It looks like a soup can. If you need kind of a label to attach to that, we'll go take a look at its properties. The cylinder has a lot in common with the prism in that it has two congruent bases. They are still parallel. So that circle, those two bases on the top and the bottom, will never intersect each other, and they are exactly the same size. The big difference is that we have two parallel and congruent here's the kicker, circular bases. The huge difference between the prism and the cylinder is that the cylinder must have congruent circular bases. If you don't have circles on the top and bottom or on the ends, you don't have a cylinder. In between the bases, we have a rectangle wrapped around like the label on a soup can. When we talk about height, we are still talking the distance between the bases. So we have a circular base. Within that circular base, we still have all of the parts of a circle. We have the center. Remember, halfway across the circle through the center is the radius. If you have it all the way through the center, that's a diameter. And 2 times the radius equals the diameter. The last part you need is our little h, the height of our cylinder. We're going to use the same idea for the volume formula as we did with the prisms. Volume is still area of the base times the height. But because with a cylinder, you only have one possibility for a base, we can be a little more specific with our formula. We know the base is a circle. And it just so happens that we know the area of a circle. So that's pi r squared times the height. This is going to be our working formula. So let's go try it. Let's go find a cylinder. Here we go. How do I know it's a cylinder? Well, it has two circular, parallel, congruent faces called bases, and they're connected by a rectangle that's been wrapped around them. My formula is pi r squared h. Now, if I go and look at my picture, they don't give me the radius. They give me diameter. If the diameter is 4, that means each piece, each radius, has to be 2 inches. And I know the distance between the bases of my cylinder is 3, so that's going to be my little h. And I'm all ready to go and start plugging things in. So my radius was 2. And the height was 3. And let's see if they gave us a specific value for pi. It just says to find the volume, round to the nearest tenth. So we are going to use 3.14 for pi. So 3.14 times 2 squared. Let me go back and put parentheses there so it looks like what I wrote. Times 3. So that gives me 37.68. And I know there were rounding instructions. Round to the nearest tenth. So the tenth is 1 decimal place. That means we need to go and look at 1 decimal place beyond that. The 8 is bigger than or equal to 5. So that means when we round, we're going to bump that 6 up to a 7. And we were measuring in inches. So this is going to be cubic inches. Let's see if we have one more cylinder we can do. We already did one sideways, so we'll do one that's standing up straight. I'm going to identify my bases. So there's my base. They give me a diameter. That's 40 miles. It's a big circle. So my radius would be half of that. That'll be 20 miles. The height of my cylinder is 11 miles. And I'm ready for my formula. We know volume is pi r squared h. We used 3.14 for pi in the last one, so we will use it here too. The radius was 20. And the height was 11. I'm going to pull out my calculator again. So we have a total volume of 13,816. And we are measuring in miles. So that would be cubic miles. The big things with the cylinders to remember is that you have to have a squared on your radius, and to pay attention to what they ask you to use for pi. If they don't specify, you can use 3.14. If they specify a value, you need to use the value that's asked for. Be careful with your rounding. And in the next video, we'll take a look at the next solid.